In this video, you are going to continue to learn about density. So like I had already taught you, mass divided by volume equals density. So you already learned that density helps us identify pure substances. However, in this video, you're also going to learn that density helps us identify if something's buoyant or not, meaning if it floats or it sinks. So hopefully by the end of this video, you understand even more ways that we use density. And it's just another reason why I love finding density.
So what are we going to learn in this video? Well, first we're going to learn what density is, and then we're going to learn how to calculate the density of an object. So density is a measure of how much stuff there is compared to the amount of space that stuff is taking up. Mass is a measure of the amount of stuff, and we use units like grams and kilograms. Volume is a measure of the amount of space the stuff is taking up, and we use units like gallons and liters and milliliters and centimeters cubed. It's a measurement that compares the mass of a substance to its volume. So for example, water has a density of 1 gram per milliliter. So that means that if I have 1 gram of water, it's going to take up exactly 1 milliliter of space. So in my water bottle, I have 500 milliliters of water. And so I know that water is going to have a mass of exactly 500 grams because it's 1 gram per milliliter. So this brick, on the other hand, has a density of about 2 grams per milliliter. And so it's more dense than water. And so if I were to put this into water, it would sink because it's more dense than water. I couldn't really use my water bottle to measure the amount of space that this brick is taking up. So milliliters wouldn't be a very good unit of measure to measure something that's solid like this. I can't pour it into my water bottle. For solid stuff like this, we like to use the units of centimeters cubed instead of milliliter. And I could physically measure this brick's volume. It's a rectangle, and so I can measure its length times its width times its height and calculate its volume. And so if I measure everything in units of centimeters, I would have centimeters times centimeters times centimeters, and my answer would be in centimeters cubed. So that's where that unit comes from. Now the cool thing is that 1 centimeter cubed is the exact same thing as 1 milliliter. They're equal to each other. For liquids, we like to use grams per milliliters as the unit of density, and then for solids, we like to use grams per centimeters cubed. Each substance has unique density, and we can use the density to identify an unknown substance, like this gray metal. What is it? Well, it could be a lot of things because there are a lot of metals that are gray. If we know its density, though, we can identify what type of metal it is. It has a density of 7.13 grams per centimeters cubed, and I can look through this table right here, and I can find that the metal is zinc. So how do you calculate density? Well, we use the equation density is equal to the mass of the substance divided by its volume. Let's try using the equation to solve a problem. Determine the density of a block of wood if the wood has a mass of 150 grams and a volume of 225 centimeters cubed. Notice that the wood is a solid, and so we use units of centimeters cubed for the volume. So here's our equation, D equals M over V. That's density equals mass divided by volume. And we can plug in the numbers. The mass is 150 grams, and the volume is 225 centimeters cubed. So we have 150 divided by 225. And so the density of the block of wood is 0.667 grams per centimeter cubed.
So if the density of the wood is 667 thousandths gram per cubic centimeter, let's compare that to water. I know that the density of water is equal to 1 gram per cubic centimeter. So when I compare the wood, its density of 667 thousandths of a gram per cubic centimeter, and the density of water is 1 gram per cubic centimeter, I just need to compare the grams because the volume is the same. So 667 thousandths versus 1. So is my wood going to be more dense or less dense? So just by comparing the mass, I can identify. And so this also decides Is my wood going to sink to the bottom? That means it's more dense than the water. And if it's less dense than the water, then my wood is actually going to float in the water. So that is why density is important. It can identify the substance because each substance has its own density, but it also identifies if an object is going to sink or float in water.
So did you learn everything in this video? Well, if you did, you learned that density is a measure that compares the mass of an object to its volume. We measure the volume of liquids in milliliters and the volume of solids in centimeters cubed. Density can be calculated with the equation D equals m over v.
Next, you're going to see an experiment that shows how density identifies if an object floats, meaning it's less dense than water, or it sinks, meaning its density is more than water. So this is an experiment that pertains to Diet Coke and regular Coke. So besides identifying pure substances, density also can tell me if an object is buoyant or not.
It's all about sink or float density. You saw the Diet Coke suit in the show. Now let's learn a little bit more about the science behind that. Density is a physical property of matter. And remember, all matter does two things. It takes up space and it has mass. That's a good rule to remember. Matter takes up space and has mass. For example, these two objects right here are made of matter. Matter is the stuff that things are made out of. And you can say that both of these are the same size and they're the same shape. Something that's the same size and the same shape, we call that congruent. However, if you could feel these the way I'm feeling them, this one has a lot more stuff in it. It has more mass in it than this one. We can open them up and find out why. This box is empty, nothing in it except for air. This box, though, I filled with marbles. And so this is a good example of how two objects that have the same size and the same shape will have a different physical property of density. But density is just one physical property. In this particular case, it's a solid. A lot of times, what we want to do with density is we want to look at it compared to water. Water is kind of our universal comparison for things that are dense. If they're more dense than water, they will sink. If they're less dense, they will float.
So remember, the density of water is 1 gram per cubic centimeter. But you know what? That's also equivalent to 1 gram per milliliter. Because remember, 1 milliliter is equal to 1 cubic centimeter. And we can also see that one more way. 1 milliliter is equal to 1 cubic centimeter. This is a way that you may see with cubic centimeters being cc, but the way that Mrs. Coble prefers is cubic centimeter with that flying 3.
Float. That brings us to a pretty cool investigation we can do called sink or float. So once again, let's take a look at these objects. You've learned to make good observations. You know that these are both the same size, they're both the same shape, they're made by the same company. They're also both cylinders. If I look on this one, it says that it has 355 milliliters. This one's 355 milliliters. So all of those things are control variables. That means on this investigation, we want everything to be the same except for one thing. And what's different is that this is diet and this is regular. So the diet will be our experimental variable. A little bit about human error also. When you do this, you want to make sure you do it the same each time. So there's a little technique, a little trick I want to show you. When you put this down in here, this bottom concave cavity could trap air, and that might mess up your investigation. So when you put this down, the first thing you want to do is burp it like that so we know we're getting all the air out of it. Now my prediction is that since this one is feels a little bit lighter, I think it's going to float in our universal indicator water. The way to do this is to take tests. And my first test I would write down is that it floats. But scientists, we like to collect lots of data on things. So I would do this a bunch of times. In fact, I would like all of you to try this. The more people that try it, if it works the same way, maybe our hypothesis can turn into something else called a theory. But right now, we're just seeing if this diet will float. Second time, floats. So as I do this more and more, I collect data and I keep trying, burping it to see, and it's floating. It's important to remember that if I change the liquid, that might change our investigation. So we want to remember to control those variables. All right, so this one seems to float. That would tell me it's less dense than water. Let's see if this one does. I burp it, and there we go, and I let go if I get all the water out, and what do you know? Sinks. And so, like most things in science, we should try it again, see if we can replicate it over and over again. That's very important. As a matter of fact, I'd like you to try these directions and see if it works. If it works the same, that might help me. If it doesn't, it gives us a lot more questions for us to try to answer. It looks like I've trapped, there goes the burp. You saw that one was floating for a while and it burped out of there. So this is a kind of a cool thing to do. So remember, if you're going to do a Diet Coke suit, you might float. Don't try a regular Coke. It'll sink. This leads us to a lot more questions. One question is, why is this one heavier than this? I'll leave that investigation up to you. But I'm going to leave you with one more challenge. Let's get this guy back down in here. And remember, we're trying this in water. So if I get that out, this one should sink. And there it goes down to the bottom. Looks like there's some air in. Let me see if I can get the rest of that air. There we go. This will go down to the bottom. Is there anything I could do to make this one come up? I hope you're thinking, I could put my hand in there? No. I could maybe use a stick? No. But if we changed the density of this liquid, maybe we could get something more dense and will float in there. And I just happen to have something to try this. I have a substance here that you can find in your kitchen, and you've probably used it. And what I'm going to do is pour this in. If you haven't guessed by now, this is salt. And so what I'm doing is I'm turning fresh water into salt water. And salt water has a different density than fresh water. In fact, it's more dense. And if what happens, what I think will happen, as we add more of this in here, this should cause this density of this liquid to change, and look what's happening. Without even touching it, I'm changing the density of this liquid, which has caused the Coke to come up and float. So you can either change the density of the object, or you can change the density of the liquid it's in. Both cool physical science investigations. Density, there's one more thing we can do. We can actually use some math to help figure out this density, because density is nothing more than the mass over the volume. And to do that, I'm going to use this pretty cool instrument right here. This is a triple beam balance. And it balances. We put something here that balances out this side to find the mass. And so once again, I did a little trick here. I thought maybe it's the CO2 in the Diet Coke that causes it to float. So what I've done is I've set out two completely degassed Diet Coke and regular Coke. And one of these is going to be a different density, we think. So let me put this on here. And one way to find this is, since the volume is the same, what we need to do is find out if the mass is the same. And so right now I can tell that this one is about, as I come up here, I've moved these on, and this one, it looks like it's about 277 grams. All right, we'll put this down here and we'll try this one. Same volume, same material, no carbon dioxide. The only thing that's different is this one is regular and this one is diet. And something interesting has happened already. It's much less. I'm going to have to take some of the masses away. And matter of fact, I'm going to have to take 10 away, add a few more. And this one is about 7 grams of mass less than our regular. So in science, it's always good to test it and to use math, because a famous person once said, math is the language of science. I'm Rick Crosland. Join us on our next Indiana expedition.
Now that you've learned some more about density, I need you to answer the questions about this video that you were given, and then turn your answers into your class's tray. Make sure your name's on it, otherwise I throw it in the garbage. Good luck, and if you need to, rewatch the video.